So hi guys, this is Mission from Keep It Up with Sean, and today we're now in the video number 8 of this lecture series, and we are going to talk about the physical properties of soil, particularly soil water, consistency, aeration, and temperature. So I hope nakita nyo yung the past 7 videos, and I hope makatulong yun sa inyo in your preparation for the upcoming board examination. Soil water, bakit siya importante? Because soil water is the universal solvent and the agent of translocating solutes to plants and carry nutrients. So kahit pa gaano kadami yung available nutrients sa lupa nyo, and then kahit pa gaano kadami din yung in-apply yung abono, if the soil is dry, it's still useless because those nutrients that are present in the soil and the one that you apply will not be available for plants kasi hindi nga siya na-dissolve and it will not be translocated to other parts of the plants. Ano ang properties ng water? Water is a simple compound with hydrogen and oxygen tied by covalent bonds and each hydrogen proton sharing one electron of oxygen. So, ang chemical formula ng water is H2O. The side of the hydrogen atoms tend to be electropositive while the opposite side is electronegative. Thus, water is dipolar, and the positive end attracts the negative end of the other water molecules, resulting in polymer-like grouping. Because of this electronegativity, it causes water to be attracted to a lot of nutrients, particularly sodium, calcium, and potassium, and make them hydrated. The polarity of water causes dissolution of salts in water because the ionic components have greater affinity for water molecules than for each other sodium chloride, as well as it also causes water molecules to be attracted to negatively charged clay surfaces. Describe in your own words what happens to the water in the diagram below as it is added to a dry soil. How do you think the water will enter and move through the soil? Now, there are two forces acting on water. So, we have adhesion and cohesion. Ano ang kaibahan ng adhesion at cohesion? Adhesion is that this is the force of attraction of water to solid surfaces like soil water to clay particles. Samantala ang cohesion, this is a force of attraction of water molecules to water molecules. So, yun yung kaibahan nila. Adhesion is attraction ng water to solid surfaces. Water to clay particles or samantala, ang cohesion is water to water. So, yun yung difference ng dalawa. Nasabi ko kanina that water is dipolar. So, meron siyang positive at saka meron din siyang negative side. Here, in adhesion water, there is an attraction of water to solid surfaces. So, solid water to clay particles. And this is held by strong electrical forces, which has low energy. And there will be a little movement as it is held tight by soil, exist as a film, and they are unavailable to plants, and this water can be removed from soil by drying in an oven. So, meron yang, for example, makita nyo yung drawing na yan. So, that's adhesion. There is an attraction of the soil and the water. In cohesion, so cohesion is the force of attraction of water molecules to water molecules. So these are held by hydrogen bonding when the negative and the positive side of water molecules are close together. So nag-a-attract sila. And these are a liquid state in water film. And this is the major source of water for plants. And with this, there's a greater energy than adhesion water. So kita nyo yung drawing na yan. Cohesion is there's an attraction between the water molecules to water molecules. Because of this cohesion and adhesion forces, it causes capillary movement of water on soil pores. What is capillary action? This happens when the water molecules are attracted to the sides of the solid and spread out in response to that attraction. And this is because of adhesion of water on the walls of channels. So meron ngayong attraction between water and the solid clay particles. So walls ng soil channels. Second is there will be a surface tension, cohesion, which results in any form of water except that a flat plane at the air-liquid interface. And the height is inversely proportional to the radius, which means that the capillarity is greater in fine textured soils than in coarse textured soils. So there will be higher capillarity in clay soils than in coarse textured soils like sandy soils. We also talk about soil water potential. This is the amount of work that must be done per unit quantity of water in order to transport a quantity of water from a pool of pure water to the soil water. So this is the soil water potential. And this is the sum of, the total soil water potential is the sum of matrix potential, gravitational potential, and osmotic potential, wherein you can find the salts. So total siya ng matrix, gravitational, at saka osmotic potentials. And as the soil dries, the matrix potential decreases or a larger negative number. Tension is pressure. Kapag ang lupa ay saturated, so meaning saturated siya ng tubig, ang kanyang water potential ay nasa 0. So kung titingnan mo yan, mayroon tayong saturated, wet, dry, and then meron din siyang very dry. Kita nyo yung mga value sa taas. From 0, nagiging mas negative na yung kanyang value. So from 0 to saturation, yung very dry na lupa ay nagiging minus 100 yung kanyang soil water potential. So in this case, dito sa rice field, kasi saturated ng tubig yung lupa, so the water potential dyan will be 0. Meron naman tayo dyan wet. Kita nyo yung bulate. And then, we have there very dry soil na nagka-crack na yung lupa. And then, here you can expect a very high negative number. Difference in energy level between pure water in the reference state and soil water causes the soil water potential. And the difference in energy levels of water from one site or condition to another determines the direction and rate of water movement. So pag may difference na kanyang energy level, it will now determine the direction and rate of water movement. So here, the soil water potential, the water is held in soil by tension or attraction of water molecules to solid surfaces and to other water molecules. Meron tayong 4 kinds of potential, water potential. So we have there gravitational potential, we have submergence potential, matrix potential, and we have osmotic potential. Ano ang kanilang properties? So when we say gravitational potential, this is the force of gravity acting on soil water, attracts the water towards the center of the earth. So gravity, pinupull niya. Kaya meron tayong gravitational potential. And then we also have submergence potential, and here, the positive hydrostatic pressure associated with the weight of water in a saturated soil. And then we also have matrix potential, and here, the negative pressure is due to the attractive force between water and the soil matrix. And then we also have osmotic potential, which is the potential energy of water as it is reduced by the presence of solutes. The tendency with which water is held in the soil is an expansion of soil water potential. Later, we are going to look on that mamaya. So, ito yung instrument to measure the attraction of water in the soil column by adhesion and cohesion. Ang tawag dyan is tensiometer. And in the preferential flow, the water travels quickly down large soil pathways, such as connected macropores, and this leads to the quick dispersal of pesticides and other toxins into the soil and finally the groundwater. So we have here infiltration, percolation, and wetting front. Infiltration is the process by which water enters the soil pore spaces and becomes soil water. Percolation, on the other hand, is Once the water is in the soil, it moves through the soil column by percolation. So, ang infiltration is, yun yung pag-enter ng water dun sa pore spaces. Samantalang ang percolation, nandun na yung tubig. Bumababa na lang siya, nag-move na lang siya through the soil column by percolation. And we also have wetting front. It is a sharp boundary demarcating the transport of water through the column. Kasi hindi naman siya pantay-pantay nag-move down. So meron niyang iba't iba yung kanyang boundary. So water in the soil is attracted to the surface of solids and to the soil solutes and by gravity. Thus, plant roots must exert effort or work to draw this water. The greater the moisture content, ibig sabihin pag mas basa yung lupa, the lower the pressure or force needed to move the water or vis-a-vis. So ibig sabihin pag yung lupa mo ay basa, ang plant roots ay hindi siya nahihirapan, hindi na siya kailangan mag-exert ng too much effort kasi nandun yung tubig. But then if the soil is dry, kailangan niya talaga niyang magsikap na makahanap siya ng tubig kasi it needs water to grow. So the pressure is called the soil moisture tension or SMT. So water moves from the region of low moisture tension to a region of high moisture tension. And SMT is high in dry soils as it needs more force to draw the water. So parang tayo, if we are being spoon-fed, sanay tayo na nandyan na yung available nodes, available materials. Hindi na tayo masyadong nag-exert ng effort to dig more, to more research like that. Kasi sanay na tayo na nandyan. Parang mga plants din, pag merong tubig palagi, yung root system ng tanim is hindi na siya masyadong nag-work. Wala siyang stress kasi available na yung tubig. But then kung kukunti yung tubig, yung root system niya, kailangan talaga niya maghanap ng tubig para siya ay mabuhay. So ganun yun. So kailangan niya mag-exert ng effort para siya makahanap ng tubig. So SMT is high in dry soil, mataas yung tension pag tuyo yung lupa kasi kailangan niya ng more force to draw the water. And water is held more strongly in fine textured soils like clay loam or clay than in coarse textured soils like sandy loam and sand, as there are more micropores in fine textured soils which stores the water. So this is the unit of soil moisture tension. So we have here the centimeter of height of water. And then we have also the atmosphere or ATM, which is 14.7 pounds per inch. And bar, which is equal to 1 atmosphere, or the millibar, which is 1/1000 bar. We all know that water has energy. The substances tend to change from a state of high energy to state of low energy. Kita nyo yung tubig in sapa, in mga ilog like waterfalls, it always run downhill due to gravity. So nagfo-flow talaga siya. Hindi siya nakastill. There will always be movement of water because it has energy. So soil water potential here, the water is held in soil by tension or attraction of water molecules to solid surfaces and to other water molecules. There is a classification of water, and this is a way to quantitatively describe the water in the soil. So we have gravitational water, field capacity, permanent wilting point, hygroscopic water or hygroscopic coefficient water, available water, and unavailable water. So itong classification na to, this is done para alam natin kung gaano ba kadami yung tubig na nasa lupa. Gravitational water, this water is not available and it has a bar of 0 to minus 0.3 bar. And then we have field capacity, which is 0.3 minus 0.3. And we have wilting point, which is minus 15 bar. And between minus 0.3 and minus 15 is plant available water, or this available water content. And minus 15 to minus 100 bar is at stages of air dry. And minus 10,000 bar is an oven dry soil. So tuyong-tuyo na yung lupa, walang tubig. So all of the water is being drawn out. Gravitational water exists in macropores. It has greatest energy, which is true liquid, and it moves freely due to gravitational forces. This is the water between saturation point and field capacity. This is not retained by the soil or is converted to capillary water when it drains to unsaturated soil layers. And you can also find this in the macropores after heavy rain or irrigation drains. And hindi siya available to plants. For example, plant in a pot. And then you are going to irrigate your plant, your isang tabo ng tubig, and then you pour it there. And then when you notice, the water is going to drain. And those are example of gravitational water. Nagmo-move siya downwards because of gravity, and it will not be available for plants kasi nawala siya, hindi siya na absorb dun sa soil mismo. So those are example of gravitational water. Then we also have field capacity. This is the water content in the soil after the gravitational water has drained out. So this is the water left around 2 to 3 days after heavy rain when soil becomes saturated. Here, air instead of water occupies the macropores, and the micropores and capillary pores are still filled with water. So the pore space is filled half by air and filled half by water. And the soil moisture tension here is measured at minus 0.33 atmosphere or minus 1/3 bar. And this is the maximum amount of the upper limit of available water. Then we also have the permanent wilting point. This is the time at which plants have removed all of the water from the capillary pores and no more available water remains in the soil. The soil moisture tension is measured at minus 15 atmosphere. And because dry na yung lupa, plants start to wilt due to less available water for absorption, and it will not recover even if you apply irrigation. So this is the lowest limit of available water. We also have the hygroscopic coefficient water. Here, the water is held at soil moisture tension greater than minus 31 atmosphere, and the water is in vapor form and not available for plant use. And then we have available water. Here, the water is held in the soil between field capacity and permanent wilting point. So the formula here is available water is equal to field capacity minus permanent wilting point. And it comprises the soil solution and is a major source of water for plant growth. Then we also have unavailable water. Here, the water content when the soil moisture tension is greater than minus 15 atmosphere or permanent wilting point. Hindi na siya available for tanim. So here, kung titingnan mo yung picture, isuzoom ko lang siya ha. So this is the picture, and here you can find I don't know if it's a river. So meron kita nyo siya dyan, may side na basang-basa, meron namang side na basa, and then you have there a degree of dry soil. So, pag yung lupa na saturated ng tubig, yung kanyang water tension dyan is measured at 0 bar. So, hindi kailangan niya mag-exert ng effort kasi may tubig. When you look at the red line, you can find there the soil is not anymore saturated by water, pero basa siya. And that is the field capacity. It has a measurement of minus 0.33 bar. And then we move on to the blue line. Medyo basa siya, pero makikita mo siya medyo darker pa yung color niya, pero medyo tuyo na rin siya. And then you can find there the bar, which is minus bar. And as the soil dries, pag natutuyo yung lupa, mas nagiging negative yung kanyang soil water tension. So here in the black line, yan, kita nyo, talagang dry na yung lupa. So it has now a water tension of minus 15 bar. So the water below the water surface is a positive potential or pressure. So pag ang lupa is saturated with water, it has a 0 bar, and below the water surface has a positive potential or pressure. But then water above the free water surface is under tension or has a negative potential. This is a picture of soil particles with forms of soil moisture. Here above, you can see that the soil moisture availability is increasing. And then we have there the hygroscopic water in the left side, capillary water, and the gravitational water. Take note that the hygroscopic coefficient water, these are water na in vapor form. Isa-isahin natin. When you look at the left side, the first one, water is unavailable for plants. You can see there the salt particles, and these are mostly in hygroscopic water. Ibig sabihin, dry yung lupa. The hygroscopic water means that the water is in vapor form, and most of the water is not available for plants. And then, you can find there the wilting point. So, ito yung time na nagwi-wilt yung tanim. And then, you can find there, after the wilting point, you can find capillary water. So we all know that capillary water works with two forces. So we have there the adhesion and cohesion. Ano nga yung adhesion? Adhesion force is the attraction of water to clay particles. Adhesion naman is a force attracting water molecules to water molecules. And then when there's a lot of water, you can see there in the right side, between field capacity and saturation, you can see there that there's a lot of water present in the soil particles. So fully filled siya with water. And then you can find there's an arrow moving downward, and that is gravitational water. Some capillary water is bound to hygroscopic water on soil particle, and it is also unavailable. Ito yung mangyayari sa lupa when there's different kinds of moisture available. So, na-mention natin kanina na gravitational water is from 0 to 0.3 bar. Minus 0.3 bar is field capacity. 15 bars is permanent wilting point. Between minus 0.3 and 15 bar is plant available water. And minus 15 to 100 bar is stages of air dry, and minus 10,000 bar is oven dry soil. This is another picture showing what happened to soil particles when it is saturated with water. So the soil particles there in the left side with the blue is filled with water, and all pores are full of water. And because of gravitational force, the gravitational water is lost. Then we also have there field capacity. Field capacity happens when there's available water for plant growth. So yan siya. So mayroong naka-stored na water sa mga soil particles. And then we also have there the wilting point, the permanent wilting point, in which no more water is available to plants. Kung matatandaan ko, Dr. Paningbatan, our teacher before in soil physics, explained it to us by comparing it with a sponge. Sponge. Yung ginagamit natin panghugas. I-dip mo yung sponge sa water, punuin mo yung sponge ng tubig. Some of the water is going to drain from the sponge. And those water coming from is the gravitational water. First, saturated siya with water. And because dahil sa sobrang dami ng tubig na nandun sa sponge, mag-start ng bumababa yung tubig hanggang sa madrain siya. So those water coming out from the sponge are called gravitational water. You try to squeeze the sponge, so hindi na siya saturated with water, basa na siya, and then there is no any gravitational water coming out. Wala nang tubig na pumapatak dun sa sponge kasi na-squeeze niyo siya, basa yung sponge, and that is how you compare it with field capacity. So that is the condition in which our soil looks like. Basa siya, so there is still water available for plant use. You let it stay there, yung sponge na yon, you let it stay for maybe 1 day, pabayaan nyo siya, nandun lang siya. And you will see that the sponge is going to become dry. And that is how wilting point is. There is no more water available to the plants, and ganyan din yung status ngayon ng soil, just like the sponge, when there is no exposure to water. I hope Dr. Paningbatan will, I think that was 20 years ago, pero natandaan ko pa rin yung station ni Dr. Paningbatan. So I hope nakuha nyo yung point ng field capacity, gravitational water, at saka permanent wilting point. So, we mentioned it before about infiltration and percolation. Ano pa nga ba ang kaibahan nila? Infiltration is the process by which water enters the soil pore spaces and becomes soil water. Samantalang ang percolation, once the water is in the soil, it moves through the soil column by percolation. And we also have the wetting front, in which it is a sharp boundary demarcating the transport of water through the column. This is the example of a wetting front 24 hours after 5 cm of rainfall. Nulan ang lupa ng 5 cm. So this is makikita mo yung soil surface basang-basa. And we have an AP horizon, which is an plowed A horizon. And you can see there the wetting front. Yung boundary niya, makikita mo na, yun. Hindi naman yung flow ng tubig, hindi siya ganun ka, pantay-pantay. So, it will be different. And that is the wetting front. Ito yung boundary. And there will be a subsoil dried by plant roots. And there will be some moist substrates. This is also an illustration showing you different condition of soils at various proportions of pore spaces. So we have there saturation when the soil particles are filled with water and there's gravitational water coming out, and during the field capacity and the wilting point. Sa baba, solid, and we have pore spaces. So all of them has 100 gram of soil, and then nagkakaiba ngayon yung percent pore spaces depending on the condition of soil. When we look at saturated soil, it has a 100 gram of solid space, and the 40 milliliter is filled by 100% water. But then during field capacity, when the soil has a field capacity condition, the 100 gram of soil, and then instead of 40 milliliter of water, half of that is filled with water and half of that is filled with air. During the wilting coefficient, it's around 10 milliliter consists of water and 30% of that consists of air. And with the hygroscopic coefficient, when the form of water is almost as vapor, there will be only 8 milliliter, and then the rest is occupied by. This is also the cross-section of our root surrounded by soil in wet and dry conditions. So you can see here in the left side, ito yung root system, roots in the soil in wet. Samantalang dun sa right side is what happened to the root when it is in dry condition. Roots are surrounded by soil in wet condition. The root is bigger. Samantalang sa right side, pag dry yung lupa, ang nangyayari ngayon sa roots, it will shrink. Miliit yung kanyang diameter. At saka, since lumiliit nga siya, ibig sabihin, nasa stress siya kasi hindi siya makapag-function properly. There are different ways in expressing and measuring water content. Gravimetric method, which is by weight, volumetric method by volume, and the depth of water. How do we calculate them? In gravimetric method by weight, you take a soil sample, you weigh it, you dry them in an oven between 105 and 110 degrees Celsius for 24 hours, and then you weigh again the sample to determine how much water was lost. Formula for gravimetric method is fresh weight minus oven dry weight divided by oven dry weight times 100. So this is the formula for gravimetric method. Hope matandaan nyo siya. It was just fresh weight minus oven dry weight divided by oven dry weight times 100. Samantalang sa volumetric method by volume, this is affected by the bulk density and the density of water. You need the data that you calculated for the gravimetric method, and then you multiply it by the bulk density divided by the density of the water. And we all know that density of water is 1 gram per cubic centimeter. So it's just basically the gravimetric moisture content times the bulk density. Then we also have the depth of water, which is usually measured in centimeter. And the depth of water is calculated by the volumetric moisture content divided by 100 times the depth of soil. So, depende ngayon kung gaano kalalim yung lupa mo. Then we also have another way to test and measure the water content, and that is through neutron scattering. As neutrons are emitted into the soil, and when they collide with a hydrogen atom, the neutron slows down and it is counted. The third method of measuring water content is the TDR, the electromagnetic method or the time domain reflectrometer. It measures the reflection of electromagnetic signals by soil water. So medyo mahal ang equipment na to, guys. Kaya mostly ginagamit is the gravimetric moisture content determination or the volumetric moisture determination. These are the approximate measurements of available water at different soil textures. So we have here coarse sand, fine sand, loamy sand, sandy loams, fine sandy loam, loam, clay loam, silty clay loams, silt loam, silty clay, and clays. And here you can find the available water capacity at 30 centimeter depth. So pag, for example, when you have coarse sands, masyadong kukonti lang yung amount ng water na available at 30 centimeter depth. Nasa ano lang siya, 0.25 to 0.75 inch. Samantalang when you have clay, kasi syempre yung tubig na in clay soils has now an available water capacity of around 1.2 to 1.5 inches per 30 centimeter depth. This is just a guide para meron kayong idea kung ano yung available water capacity per soil texture. Now, balikan natin yung question kanina. Describe in your own words what happened to the water in the diagram below. Anong mangyayari pag nilagay mo yung water in a air-dry soil? What do you think will happen to the water? Will it flow downwards? Will it flow sideways? The answer is the water moves sideways and downwards at same rate. This is because of adhesion and the cohesion. Yung forces na na-mention natin kanina. And would the movement be different if the soil was saturated? Yes, the movement would mainly be downward due to gravity pag yung soil mo is saturated with water. How do you think water will move if the soil has loam and then below the loam is sandy soil? We have here T1, time 1, T2, T3, and T4. The waterfront does not move into sand until loam is saturated. So, kailangan mapuno muna yung loam. And then, if the loam is saturated, dun pa lang siya mag-percolate papunta sa sandy soils. And what about loam with clay? Ang mangyayari dito, waterfront moves into clay upon contact with clay, but because it moves slow, water builds up above the clay layer. So mapupundo ngayon yung tubig dun sa ibabaw ng clay kasi mahina yung kanyang pagbaba sa tubig. We also have water management. This is the control of water for optimum crop yield and the best and effective use of a limited supply of water since it is a scarce resource today. Syempre guys, ang hirap, ang mahal ngayon ng tubig and not all areas, agricultural areas have water available for irrigation. Kaya kailangan talagang i-manage properly yung water. This is the world total water. 97.2% of the water comes from the ocean. And only 2.8% is fresh water. So ang liit lang na freshwater sources. And of that 2.8% fresh water, 2.15% is coming from glaciers, glacial till, yung mga transported materials from ice. Then 0.65% is groundwater, yung galing sa mga balon natin or poso. And 0.001% is coming from the streams. Ito yung mga sa rivers, sa mga sapa. And then 0.009% is coming from lakes, lawa. And we have 0.008 from seas. And 0.005 from the soil and 0.001% from the atmosphere. So ang liit lang ng fresh water, ng sources ng fresh water. The rest is ocean, salty yung tubig. So here in the graph, you can find 97% is seawater, 1% is usable fresh water, and the 2% fresh water is frozen in polar ice caps. Kaya yung iba dyan, hindi siya available. The hydrologic cycle is driven by the energy from the sun, and that is the evaporation. How did it happen? The water is heated by the sun, and the surface molecules become sufficiently energized to break free of the attractive force binding them together. And these water molecules evaporate and rise as invisible vapor into the atmosphere. Pero meron din naman tayong transpiration. Water vapor is emitted from plant leaves. Actively growing plants transpire 5 to 10 times as much water as they can hold at once. And these water particles then collect and form clouds. Rain is coming from the clouds. Kaya cycle siya, guys. So the hydrologic cycle involves the continuous circulation of water in the Earth atmosphere system. At its core, the water cycle is the motion of the water from the ground to the atmosphere and back again. And of the many processes involved in the hydrologic cycle, the most important are evaporation, transpiration, condensation, precipitation, runoff. And the soil water storage determines the groundwater recharge. So this is a picture of how hydrologic cycle works. It's a cycle, guys. So saan ba tayo ngayon magsisimula? So here you can see there's a water. So when the snow melts, there will be some erosion and there will be runoff. And those water from the snow that is melted will become a runoff, and it will flow now down to the maybe lakes or rivers or anything. And those water will be evaporated, and some of the plants growing around the area is going to transpire, and the water that is being collected will form clouds, and because of condensation, it will form rain and will continue to precipitate, and it will go again into cycle. So yun yung nangyayari ngayon for the hydrologic cycle. Kaya you can see how nature works. It's very amazing. This is a picture showing the soil, water, and plant use. Here you can see in the graph, we have here in the y-axis, we have the rate of plant growth. And in the x-axis, we have there the saturation, field capacity, and wilt region. So note that here in the saturation, when the soil is saturated with water, there will be oxygen deficient because most of the pores are filled with water. So walang oxygen na present. So there will be an oxygen deficient. And then you have here the field capacity. So this is an ideal for plant growth because water is available for plants and there is also enough space for the air to occupy in the soil. So ito yung ideal for plant growth. But then when you have here the wilt region, when you have a very dry soil, there will be an increasing tension, increasing pressure and stress because the plants are getting in a lot of stress because there's no enough water and plants are going to start to wilt. So this is not good. This is the water budget. So we have here the storage, which is equal to irrigation plus precipitation plus capillary rise minus the evapotranspiration minus the deep percolation minus the runoff. So ito ngayon yung formula na ginagamit nila when they are calculating irrigation. How much water do they need to apply to the area needed for the crops that they are going to grow, depending upon the evapotranspiration and other factors affecting the area. So what determines plant available water capacity? We mentioned before that the available water capacity is equal to field capacity minus the wilting point or permanent wilting point. It varies according to the rooting depth because not all plants have the same rooting system. Some of the plants are deep-rooted, samantalang yung iba naman is medyo mababaw lang. So, may mga tanim na kailangan niya talaga ng madaming tubig sa few centimeter ng part ng soil. Meron namang mga tanim na yung gusto nila is yung tubig is nasa ilalim na banda ng lupa. And the growing stage kasi young plants and the old plants, they have also different water requirement. And also, it also considers the depth of root limiting layers and then infiltration versus runoff. Because more water entering the soil, more will be stored. And then the amount of coarse fragments, depende kung marami kang gravel or sand or ano pa yan. And also the soil texture. Because the size and amount of pores also affect. Like for example, silt loam has greatest available water capacity, followed by loam, clay loam, and silty clay loam. Pag sandy soils, medyo mababa yung kanyang available water capacity. Now, we are going to have different sample problems. Soil has the following information. So you have here the weight of cylinder plus oven dry soil, 240 gram. The weight of cylinder at field capacity, 350 grams. And then at wilting point, 300 gram. And the weight of cylinder on June 1 is 320 grams. And the volume cylinder is 200 cubic centimeter. The question is, calculate the bulk density, the percent water by weight at field capacity, the percent water by volume at field capacity, the percent water by volume at permanent wilting point, and how much water is stored at 1.2 meters soil. So, ang dami yung tanong niya guys, di ba? So, ngayon, how are we going to calculate this? So, first, we're going to calculate the bulk density. Ano nga ba yung formula ng bulk density? Bulk density is equal to the weight of the soil divided by the volume of the soil. So in this case, the weight of the oven dry soil is 240 gram and the volume of the soil, which is the volume of the cylinder, is 200 cubic centimeter. So in this case, the bulk density is 1.2 gram per cubic centimeter. And then the percent water by weight at field capacity. So we have here 350 gram at field capacity minus the 240 gram, which is the oven dry soil, divided by the oven dry soil times 100. So, eto ngayon yung sagot, 45.8%. And then, we also have water by volume, di ba? So, moisture content niyan by volume is we need the data of the bulk density. And then, to calculate the percent water by volume at field capacity, it's almost the same, guys, with the by weight. Pero ngayon, yung gagamitin natin, instead of the weight, we're now going to use the volume. So here, 350 gram minus 240 gram divided by the volume of the soil, which is the volume cylinder, which is 200 cubic centimeter times 100. So the answer there is 55%. And then the percent water by weight times bulk density is equal to the percent water by volume, or 45.8 times 1.2, which is 55%. And then to calculate the percent water by volume at permanent wilting point, so we have here 300 gram minus 240 gram divided by 200 gram, which is the volume, that is equal to 30%. And now, to calculate for the available water capacity, which is equal to field capacity minus permanent wilting point. So we calculated the field capacity, which is 55%, minus the wilting point, which is 30%. So 25% times the depth of the soil. And here, because we have 1.2 meter, so it means that 0.3 meter of water is stored in 1.2 meter of soil. There is 0.3 meter of water stored in 1.2 meter of soil. This is a calculation of estimated soil profile. Ito ay soil profile na to, guys, ha? Available water holding capacity. So we have here different soil depth. So 0 to 20 centimeter, 20 to 40, 40 to 75, 75 to 100 centimeter, and 100 to 125 centimeter. Ito yung kabuuang profile ng lupa. And then you also have here the relative root length. So may mga asterisk. Ibig sabihin na masyadong marami yung root system in between 20 centimeter, 0 and 20 centimeter. 20 to 40 is less. 40 to 75 is mas mababa. 75 to 100. Pero pagdating ng 100 to 125 centimeter, wala na siyang roots na makikita. And then you can also find there the bulk density. So 1.2. And then as you go deeper sa profile ng lupa, the bulk density also increases. So tumataas siya, nagiging mas compacted the more na sa ibaba ng lupa ka tumitingin. And then this is the field capacity. And then we also have the percent wilting percentage. So when we calculate the water holding capacity per depth, so we just multiply the depth, so 20 centimeter, times the bulk density, times 22 minus 8, divided by 100. So 22 from the field capacity minus wilting point, so which is 3.36 centimeter. Ganun din yung gawin mo sa ibang depth ng lupa. And then here, and then you just sum it up. 3.36 plus 2.52 plus 5.25 plus 3. So there is, in this example, 14.13 centimeter of water could be stored for plant use. Pero tingnan nyo, the calculation of available water holding capacity of the soil plant system includes only horizons that has penetration of roots. So hindi niya ngayon sinama yung depth ng between 100 to 125 centimeter because wala na siyang roots na makikita. So only include profile, depth ng lupa na where you can find roots system. So at a typical summertime water use rate of 0.5 centimeter of water per day, the soil could hold about a 4-week supply. So these are the considerations in water management. You have to consider the soil infiltration. This is the nature of pores and water content of soil are major determinants of soil profile characteristic. We have also the tillage, which gives a rough soil surface which controls runoff, and it also loosens soil and increases total porosity and thickness of plow layer for greater water storage. And then we also have placement of residue mulches. The end of rainy season conserves water by controlling runoff, increasing infiltration, reducing weed growth, and decreasing evapotranspiration or evaporation. So that's all for soil water. Now we'll go to the another topic. Ang haba ng soil water, guys. So I hope meron kayong natutunan doon. Now we'll go to soil consistency. And soil consistency is the physical state of the soil at various moisture levels when subjected to mechanical stress such as plowing. Pag inararo mo yung lupa, because you destroy the structure of the soil, and then the consistency of the soil will also be affected. This is affected by organic matter, texture, and the nature of clay. There are three kinds of consistency, soil consistency. We have there dry consistency, moist consistency or friable, and then we also have wet consistency. Dry consistency happens here. Sandy soils have less loose consistency and crumble easily, while clay is hard. Pag dry yung consistency. When the soil is moist, has moist consistency or friable, clay soils, especially montmorillonitic, have narrow moisture range for tillage, and below the range, they are too hard, while above the range, they become puddled. Medium textured soils have wider moisture range for tillage. Then we also have wet consistency. It is described as plasticity or stickiness. Ano nga ba yung plasticity? Plasticity is the ability of the soil to be molded. Di ba pag naglalaro tayo before nung mga bata pa tayo, mold natin siya, gumagawa tayo ng bola or gumagawa tayo ng mga manika. So that is plasticity, the ability of the soil to be molded. Sandy soils are non-plastic and non-sticky when wet. Kahit pabasain mo pa yung sandy soils, hindi siya dumidikit. And they are not plastic. Then we also have another physical property, and that is soil aeration. And this talks about oxygen availability. And this is controlled by soil macroporosity, soil water content, and oxygen consumption. When we say soil macroporosity, macro means malalaki, macropores. This is affected by texture and structure. And we also have here soil water content as it affects water and air ratio. Syempre, pag yung lupa mo is fully saturated with water, all of the pores are filled with water and there is no space for air. And then we also have oxygen consumption by respiration, including plant roots and microorganisms. Poor aeration occurs when 80% to 90% of the soil pore space is filled with water. Hindi nakakahinga kasi fully occupied siya by water. So walang available oxygen na present. So, and we all know that roots also need oxygen. Parehong tayo. We all need oxygen. And this results in little air storage in the soil. It mainly cuts off pathways of gas exchange with the atmosphere. Compaction can also result in a loss of gas exchange with the atmosphere. And when the soil has an extreme amount of excess water, it is water saturated or waterlogged. So, hindi ngayon nakakahinga yung lupa. Hydrophytes are plants that have ways of obtaining oxygen in waterlogged soils. Kasi may mga tanim naman na nakaka-survive in waterlogged areas. And these are called hydrophytes. Some grasses use parenchyma tissues to transport oxygen down the stem to the roots. They have their coping mechanism. They can adapt. They adapt to the environment. And some trees, such as mangrove, produce aerial roots to obtain oxygen. Kahit submerged siya sa tubig, nabubuhay pa rin siya because they obtain the oxygen from the aerial roots. This is the percent of gases in the atmosphere concentration in the soil. Ito yung mga present ng gases in the soil. So the soil atmosphere is consist of 78% nitrogen. Uy, ang daming ng nitrogen. So 78% nitrogen, 21% oxygen, and 0.035% carbon dioxide. Soil oxygen varies from about 20% near the surface to less than 5% at depth. So, mas maraming oxygen sa near the surface soil compared dun sa subsurface soil. Kasi nasa ilalim na siya, wala na siya masyadong exposure to oxygen. And during respiration in soils, oxygen is replaced with carbon dioxide, which could approach toxic levels. When soil oxygen becomes low, it results in anaerobic condition. So, meaning walang masyadong oxygen, anaerobic. Aerobic naman pag maraming oxygen. Carbon dioxide and oxygen have an inverse relationship in the soils. Pag marami yung carbon dioxide mo, mababa yung oxygen. Pag madami naman yung oxygen mo, mababa yung carbon dioxide sa lupa. And water vapor is usually close to the saturation level in soils. And when soils are waterlogged, ibig sabihin na punong-puno siya ng tubig, saturated siya ng tubig, methane and hydrogen sulfide can build up. And under anaerobic conditions, ethylene is produced and can be very toxic to plant roots. So there will be other gases that will be formed if the soil is waterlogged. So that is all about aeration. Now we'll go to temperature. And the temperature of the soil affects physical, biological, and chemical processes. That's why it's very important. Cold temperatures slow chemical reactions. Cold temperatures slow biological decomposition, which slows the production of nitrogen, phosphorus, sulfur, and calcium. High temperature can also inhibit biological activity or kill off microorganisms kasi yung ibang mga microorganisms and animals, they have their optimum temperature requirements. So pag masyadong mataas na yung temperature, hindi na siya nabubuhay. Naiinitan sila masyado. They cannot live. Warm soil temperatures generally induce plant germination and growth. And the seeds of plants that are adapted to open gaps react to warm soil temperatures caused by direct solar radiation. Seeds of prairie grasses require a cold period to enable them to germinate. And this is called vernalization. It depends upon the crops. Some crops are tolerant. They can grow in cold condition, while some plants, they cannot grow in cold condition. Some plants such as tulips, ang gaganda ng mga tulips, yung mga bulaklak guys, they require chilling and freezing in early winter to develop buds. So without cold temperature, the buds of the tulips, yung mga bulaklak na yun, they cannot grow. The soil microbial activity and organic matter decomposition cease below 5 degrees, which is known as biological zero. So pag mababa na by 5 degrees Celsius, most of the microbial activity and organic matter decomposition will not anymore happen. Affected siya. So 5 degrees Celsius. Ito yung tinatawag na biological zero. So zero. There will be no biological activity. Clear plastic can be used to raise soil temperature, reducing fungal diseases and control pests, and this is called soil solarization. to treat the soil, especially pag yung soil is affected by fungal diseases or other pests. So, sinosolarize nila yung lupa. They expose the soil to high temperature to kill all those, well, it's heated by fire. Fire breaks down the organic layer and recycles the nutrients into the soil. And that is why kaingan system, this is a culture. There's also pros and cons of kaingan system. And siguro nung unang panahon, wala naman silang studies pa na nagawa before, di ba? And yet, the indigenous people are doing it. Until now, ganun pa rin yung kanilang lifestyle. Meron silang lugar na nakikita, nagkakaingin sila, and they break down the organic layer and recycles the nutrients into the soil. And then after ilang taon of staying in that place, they cultivate the land, and then hanap na ulit sila ng ibang area, and then dun ulit sila, and then the area that was abandoned, some plants are going to grow, and then the cycle is going to continue and continue. Some seeds with hard coatings need to be heated above 70 degrees Celsius before they will germinate. And the heat from fire can kill some weed seeds, and fire can also cause the development of a hydrophobic layer. Hydrophobic layer. So meron siyang phobia to water. Water cannot enter this. And when soil is heated by solar radiation, kanina is fire. Ngayon naman, soil is heated by solar radiation. On average, only 50% of the solar radiation actually reaches the soil. Hindi siya masyadong nakakarating sa lupa. The majority of that energy goes to evaporating water or is reflected back into the atmosphere because of a high albedo. And only about 10% of the solar radiation actually heats the soil. Kasi syempre, mayroon din mga nakatanim doon sa lupa na yun, di ba? So it does not really penetrate into the soil directly. I hope you learned something from this topic. Medyo mahaba siya, guys. This is the end of this topic about physical properties of the soil. Let us close this topic by quotation from Daniel Hillel, Out of Earth, in Brady and Whale, in the book of Brady and Whale, 1999. Both soil and water belongs to the biosphere, to the order of nature, and as one species among many, as one generation among many to come, we have no right to destroy them. And think of the future, guys. Yung mga anak natin, yung mga apo natin, they are going to use and need water and soil. That's why it is our duty and it is our responsibility to protect these two resources. So thank you very much, and let's end this presentation. And our next video is about the chemical properties of soils. So we are going to talk about soil colloids and ion exchange. But thank you very much for watching. And if you are new to my channel, please click the subscribe button and it will help me a lot. And you can also share this video to your friend na nagre-review din para makatulong din sa kanila yung topic na to. So thank you very much and see you next time.